Have you ever wondered how scientists take a whole mess of numbers and somehow turn it into a clear, simple story? Well, today that's exactly what we're going to do. We're taking a simple, everyday observation and turning it into a full-blown scientific investigation. Let's get into it. It always starts with a simple question, doesn't it? You've got your hot coffee or tea, you see the steam rising, and you know it's getting colder. But how? Is it just dropping at a steady rate? Or is there something, a little more interesting going on? This kind of curiosity, well, that's the spark for pretty much all scientific discovery. And that little question gets right to the heart of what science is all about. It's about building real, solid knowledge and understanding how the world around us actually works. And we do that by observing things, like our cooling drink, running some experiments, and then, this is the crucial part, analyzing what we find. So let's do it. Let's take that question about the cooling drink and actually turn it into a proper scientific plan. We're going to walk through this step by step to find an answer that's based on cold, hard evidence. And you don't need some high-tech lab for this either. All we really need are a few basic tools. We've got a beaker for our hot water, a thermometer to get some accurate readings, and a timer. We're just going to take measurements over a period of time and see what happens. Simple as that. Okay, but before we start measuring anything, we need to get our heads around our variables. First, there's the independent variable. That's the one we control. In this case, it's time. We decide when to take our measurements. Then there's the dependent variable. That's the thing we're actually measuring to see what happens, the temperature. It depends on how much time has passed. See how that works? All right, experiment's done, and we've got our data. But here's the thing about raw data. It usually just looks like a total jumble of numbers. So now comes the most important part of the whole process, bringing some order to this chaos to find the story that's hidden inside. So here are the numbers we jotted down, but they're all out of order. 5 minutes, 60 degrees, 0 minutes, 85 degrees. Can you see any kind of relationship here? It's really tough, right? This is exactly why the very first step in any analysis has to be organization. And here we go. The first step is so simple, but it's incredibly powerful. We just tabulate the data. We put it into a nice, organized table with clear columns, time on the left, temperature on the right. And boom, instantly, it's way clearer. You can see the temperature is dropping as time goes on. We're on our way to finding a pattern. Now, a table is great, but honestly, a picture can tell you so much more. To really see the relationship between our time and temperature, we've got to visualize it. So let's take that next step and turn this data into a graph. And there it is. That's our story in visual form. By plotting each time point from our table and showing the temperature with a bar, we've turned those numbers into a shape. And right away, you can see the temperature is dropping. But now, let's look closer at the pattern of that drop. So, with our data all graphed out, now we can do the real work of a scientist, analysis. We're not just looking at a bunch of bars on a chart anymore, we're hunting for trends, for patterns. We're looking for the relationship between heat and time. And this is where the big insight happens. Just look at the difference between those bars. That first drop, in the first 5 minutes, it's huge. But then the next drop is a little smaller, and the one after that is even smaller still. This tells us something absolutely crucial. The cooling isn't constant. It starts off really fast, and then it slows down. And that, right there, is the single biggest thing we've learned from our graph. If the cooling was happening at a steady pace, we'd see a perfectly straight diagonal line. But we don't. We see a curve, and that curve tells us everything. The rate of cooling changes. It slows down over time. Okay, so we've collected our data, we've organized it, we've graphed it, and we've found the pattern. Now, for the final, most satisfying step in our investigation, stating our conclusion. This is where we finally answer our original question using the evidence we gathered. So, what did we learn? This isn't a guess or just an opinion. This is a conclusion based on our actual data. Hot water cools down the fastest when it's at its hottest, and as it gets closer and closer to room temperature, the rate of cooling slows right down. That's the story our cooling curve told us. Now, just step back for a second and look at what we did. We started with a simple question, we planned and ran an investigation, we analyzed our results by making a table and a graph, and then we drew a conclusion based on our evidence. We just walked through the exact working scientifically process that underpins all of science. So yeah, we analyzed a beaker of hot water, Big deal, right? Well, actually, it is a huge deal because this process, understanding how to do this, is fundamental to how we learn pretty much anything in science. And this is the really amazing part. The simple logic we just used for a cup of water, it's the same fundamental process scientists use for everything. Whether they're tracking global climate data, developing life-saving medicines, or mapping galaxies billions of light years away, it all comes down to this core loop. Ask a question, investigate, analyze, and conclude. And that's the real beauty of science, isn't it? Every answer just leads to a new, more interesting question. We've figured out how the water cools, but that immediately makes you wonder, why? Why does it cool in that specific curve? What's causing it to slow down? Now that sounds like a great question for our next investigation. Thanks for joining me.